In this video, we're going to be talking about F5 DNS deployment strategies. So first we'll be covering the F5 DNS exam blueprint objective 103, and we'll take these in 3 parts because objective 103 has a lot of good content that we can cover. So part 1 encompasses the 5 main architecture designs for GTM. So we'll review those. Okay, objective 103 is determining appropriate deployment integration strategies for a big IP DNS solution. So if you're given a customer environment, so you have to understand the requirements, the constraints, and then you select an appropriate deployment model. So we'll go over 5 of the main architecture designs for GTM. Okay, so let's look at the big IP DNS deployments. Now, I believe there's really 5 main architecture designs for GTM/DNS. There's many ways to slice the cake, right? So you can have a combination of these designs, or just one. So we're going to dive into each one of them, and then later you'll be able to distinguish how can you fit some of these together, and we'll touch on that as well. Alright, so let's take a look at the first example, delegating DNS domain to the big IP DNS. So we'll start out with our topology. So we have the devices and of the clients, and our local DNS server, and the authoritative DNS server, and then the data center 1 and 2, and we have a F5 DNS at each data center, and then the registrar and domain provider. So in this example, the DNS platforms are acting as an authoritative for the subdomain WIP dot, and then the domain.com is actually registered through the registrar to the domain provider for registering .com domains, and to manage the domain.com, we're using a external DNS server to manage that domain.com. So let's walk through the steps. So first we'll create a wide IP and a record for host.wip.domain.com. Alright, so we first create a delegation subdomain called WIP on the authoritative DNS server. Then in the parent zone, we'll go and create a NS records mapping the GTM NS names to WIP. Then the parent zone will create the A records for the GTM listener addresses. So let's just say 101 is part of data center 1 and 102 is part of GTM 2. Then in the parent zone, we map the host.domain.com to host.wip.domain.com. So whenever a request comes in for host.domain.com, it will point to an alias of host.wip.domain.com. Alright, so the traffic flow is the client sends the A record to the LDNS for host.domain.com, and it goes to the authoritative DNS server. The authoritative DNS server will respond with the alias to go to host.wip.domain.com, and in turn it will look up the NS records based in that CNAME response, and it knows that based off the parent zone information here, and it sends the A record query to host.wip.domain.com to DNS1 and or DNS2. So regardless of what DNS platform gets the box based on additional topology information, which we'll dive into, then both of the DNS servers actually share the DNS zone information. So in this case, it doesn't matter which DNS box gets the query. Either one will respond, and it will respond with the A record we put in here for the wide IP. Now, because it matches a wide IP, it's going to use that wide IP information as it auto-populates in Zone Runner and respond with host.wip.domain.com with the IP address to reach that site to the LDNS. Then the LDNS can basically send all the information it just received from all the iterative queries back to the client that originally asked for the request. So you'll see the CNAME and the A records for host.domain.com and the appropriate IP address for the server. Another thing I want to note is that when dealing with the registrar, we need to update the name servers of the domain provider. So this could look differently depending on if, like for instance, GoDaddy could act as a registrar and an authoritative DNS server. Sometimes it's split to where these are two separate entities. Nonetheless, the domain provider essentially registers that through the registrar based off the name of what you purchased, right? So we need to add these respective GTM/DNS name server records to the domain provider so they can update the registrar. Okay, and in addition, when we use the new name servers for the GTM/DNS for use for delegation, we add it to the domain provider, which is the registrar, which in turn syncs with the authoritative DNS server. So our GTM name servers should also show up on the external DNS server provider. So in turn, we need to be able to do a zone transfer from our authoritative DNS server to these big IP DNS boxes. So different external DNS servers obviously come from different IP addresses. So you need to ask your respective provider what IPs that we need to whitelist on the big IP DNS boxes to be able to allow the client transfer requests and receive messages. So the zone information is the same. Alright, so let's take a look at the next example. Here we're delegating DNS records or a record to big IP DNS. And the advantage here is that maybe you don't have to have a whole domain or subdomain that you need to point to DNS, and maybe you just have a handful of records that you want to point. This is probably a better option for you. So we'll start by creating the wide IP A record, and we'll use host.domain.com, and this is going to be our secondary DNS server, and we'll create the delegation subdomain called host. We will then take that host and map it to NS records for both GTMs, the respective data centers. Then still in the parent zone, we'll create the A records for the GTM listeners, public listeners, and then we'll start the flow. So the client requests host.domain.com to the LDNS. LDNS goes to the authoritative DNS server. The authoritative DNS server will respond with an alias to go to this name server instead, gtm1.domain.com or gtm2.domain.com, to resolve that original request. The LDNS takes that, points to those NS records for the A record host.domain.com, and since we have a wide IP created, then the F5 DNS boxes will respond with that proper IP address we've assigned, and then the LDNS will respond back to the client with all the information it just learned about via both the data paths. Alright, so let's take a look at another example. This is redirecting DNS queries using a CNAME pool. So what we can do here is, let's say your company has recently purchased a competitor. Call it siterequest.com. The site request administrators can redirect DNS queries for competitor.com to the rebranded site competitor.siterequest.com. So in our example, we have the DNS servers authoritative for both the domain.com and different domain.com. Now you could have just one site be authoritative for domain.com and then you redirect to a different site, so you're not having to be authoritative for both the domains. But in this case, we can simply say we merge the data for these two companies. Now we're authoritative for both, and we have that flexibility and control. So it works in both ways. So let's run through an example. So we'll start out by configuring a domain.com wide IP, and this is an A record. The A record will have a pool associated under it with the CNAME type of a wide IP for the different domains. So in this case, domain.com will point to host.differentdomain.com. And then we also create that same wide IP A record, host.differentdomain.com. So that's updated in bind or zone runner. So the flow comes in from the client device, the A record for host.domain.com, and the LDNS gets it. It goes directly to the name servers of the GTM listeners. Then one of the GTM listeners will respond with the host.differentdomain.com to the LDNS, and the LDNS will pass this information on to the client. So let's take a look at this example live a second. We'll jump to the GUI. Alright, so we'll look at our wide IP configuration. I've configured a domain.com wide IP, and this is right here, and it is an A record, and it's currently available. And then what we do in pools, well, before I get to that, the domain.com has a wildcard associated with it. Now you can use asterisks in any spot of a wide IP to reference one or more characters. So anything.domain.com would hit this, and if there's nothing more specific, there's no more specific wide IP, let's say if there's not already a host.domain.com, it'll use this wildcard wide IP. So we're using wildcard.domain.com. The pool is then referenced here, so it's a redirect domain to different domain, and it's a CNAME type. This is just the long-winded name I've chosen. Determine not to verify the member availability in the back end, because in this case we're just focused on the actual name that we're given instead of the LTM VIPs in the background. So go to members. This is the wide IP that we're configuring statically. So if you go under manage, when you add the pool, you can choose from an available list of wide IPs. Now I had to specifically type host.differentdomain.com instead of choosing from this list. Now I don't know if it's recommended as a feature to drop down, but I had to specifically type it out, and then I chose to do a static target. It doesn't change, and then you can add it to the member list. Okay, so back from the wide IP to the pool. Now back to the wide IP. We talked about adding an A record for just host.differentdomain.com. Now this is used just to put the information into the zone runner. If you were to have the reason it's red is I don't have any pools up at the moment, but what I really want to show you is just getting to the name part, so we don't have to focus on the actual LTM VIPs being up and responding. We're just focused on the names, so I don't want to complicate things. at this point. So this is just simply typing in host.differentdomain.com with an A record type right here. So let's minimize this, and we'll go to the client view. So I've got this on my desktop, and you can use Dig or you can use NSLookup. Dig is a nice tool you can install on a Windows environment, and you can see it gives you a lot of options to search for with different flags and utilities you can use inside of Dig. So we're going to start by typing in Dig, and then we're going to point to the listener address of the GTM. So in my case, the listener address, if you go to delivery listeners, it is 10.10.230, 10.1.10.230. I'm going to take that IP, copy it, and paste it, and then we're going to search for test.domain.com. Now before I type enter, let's go to the command line of the F5, and there's a couple things you can do from looking and querying the results. So you can actually take a debug command that I'll show you, and this is modifying the GTM query logging. Now, disclaimer, you really don't want to do this in a production environment. Only recommended for lab use because it can really jump up the CPU depending on how many requests you have. But it's really good for a VE lab environment, that is especially in our case. So if you run TMSH commands, you can choose to save that configuration to memory, and that's different from the GUI. The GUI will do this automatically, but TMSH commands specifically, you could choose to save to the startup configuration or the running configuration, essentially the startup. Alright, so now that that's complete, we can quit out of TMSH, and we'll do a clear to remove some of the real estate, or get some more real estate. You can do a caret sign, greater than sign, and do var log GTM, and this will clear what's currently in the GTM. The GTM log file. Okay, so now we can go and do a rolling tail for var log GTM. Now this is going to anything that gets updated in GTM, it's going to continue to give us that new information. Alright, so while that's running, we can go back to the client and do a dig to the GTM listener with test.domain.com. We'll hit enter. Okay, so right here, the answer section is what's key to us at the moment, but test.domain.com gives us a CNAME back for host.differentdomain.com. And what's nice, you could see via that debug, you can jump back to the secure CRT and look at what it's currently doing at the DNS level. So it tells us via TMM that it's resolved resource record type for an A record for WIP testdomain.com. The LDNS is actually my client in this case, so we're pointing directly to the GTM listener, so therefore we're basically acting as an LDNS server would. It's going to the VS, which is actually a wide IP, host.differentdomain.com, and it's using that pool that we created. So it's really good information to be able to see what type of load balancing it's using in the back end, and if maybe it's not hitting a specific wide IP or it goes to return to DNS, then you're able to see some of that information with that debug statement. Now we can take a look at another method used to troubleshoot, and let's jump to TCP dump. So you can type in TCP dump -NNI. That's used to not resolve IPs to names. The I is for interface. We'll specify 00, and this tells you to look for all data ports. So it's capturing all data ports except for the management, which is E0. So all the data ports, turn on the snaplin, which to full to capture the whole packet, and then we'll type in my client IP, which is 10.1.10.1, and port 53. We'll turn on some verbosity. Okay, so let's run that same dig lookup again. Okay, and jump back to the command line. Okay, so another way to view this is looking at the TCP dump too. And verbosity just allows you to see some of the decoded IPv4 headers, so like the TTL information there, which is nice to see. So we can see we asked for an A record type, testdomain.com, and this is from my client IP to the GTM listener on destination port 53. Then this is the response from the GTM on the 230 address back to the client, and it is for the testdomain.com, and the alias it says to point to is host.differentdomain.com. And what's nice is it also shows you the name of the GTM listener that it used. So in this case, 10.1.10.230 is also references DNS underscore listener as the actual name. So it's another way. It's another great way to view the DNS records coming in. And there's also profiles, which we can get to later, and local logging we can do as well. Just another tool at your disposal. Maybe one works better based on your needs, right? So cancel out of that. Okay, so I hope this gives you a good understanding of redirecting DNS queries using the CNAME. So in summary, we create a wide IP that represents the original website, a pool attached to it with the CNAME, and then another wide IP A record for that request. Also, another nice thing to do is if you want just the short answer of the request, you can do a plus short, and it'll just give you what we receive back. So instead of the question section, the answer, and the query statistics, you can just get the short answer if you're doing a lot of queries. This can be helpful for scripting out different changes to the wide IPs, and maybe you're doing just a mass collection of certain data. This may be a good option for you to use. Okay, so another option you can choose is replacing a DNS server with Big IP DNS. Okay, so let's say your internal DNS server is really not a robust management platform, and you'd like to be able to move some of the zones or all of the zones to the Big IP DNS. Maybe you want to use DNSSEC or transparent cache or rapid response DNS to better protect against DDoS. There's a lot of features and capabilities that the Big IP DNS has over a traditional DNS server. So if you wanted to fully replace it, you could run through those steps. So the 5 steps here I've listed, we can use a different self IP than what the internal DNS server. Obviously, we don't want any duplicate IPs, right? So we configure the DNS self IP. If these are set up in an HA pair, so you have 2 per data center, then it would be the floating self IP. So we'd use a different IP address, and then we would perform the zone transfer to your existing internal DNS server. All right, so we're sending a zone transfer request. So this is coming from the F5DNS self IP to your internal DNS server. Okay, and you'll see different structure laid out through different DNS systems, but you'll see some mention of an allow transfer and also notify. The allow transfer message has to have the IP address of the F5 DNS self IP address. Okay, the also notify will list the listener. So the DNS server will notify the listener address. So notice the source is the self IP address here, and then the destination is the listener address of the big IP DNS platform. So there's a distinction there. So what a zone transfer request is basically taking all those records of an authoritative zone and basically copying over all the pieces of it to the big IP DNS platform. Alright, so once we have all the zones that we want from the internal DNS server and the zone transfer is complete, then we can disable the DNS interfaces to prep for a maintenance window, right? So we have what we need, we're disabling those interfaces, and then we're changing the self IP to the same IP address as the internal DNS server. So while you're doing this, it would be kind of a one full maintenance window. You know, you disable, you change it to the new IP address of the internal before you flip on the interfaces of the big IP DNS system. You will decommission the old, well, now the old DNS server, unrack it or whatever you need to do, and enable that the DNS interfaces. So it's kind of a two-step quick effort there at the end. And what's nice about this is if you have clients that used to go to the legacy DNS server, well, now they're pointed to the self IP address of the DNS server because the IP address stayed the same. So it's really nice. You don't have to worry about legacy clients still pointing to the F5 DNS and have it exactly set. So let's run through a flow, and it's really going to look the same as it did with the normal requests, but now that the process is really taken over by the F5 DNS. So the client sends a normal A record request to its LDNS. The LDNS in turn, if it doesn't have it in cache, will send a new request to the NS records for the two F5 DNS platforms, and one of them will respond with the available IP address, and it uses wide IP first. So if you've got a static wide IP set, it'll use that information first. You could use F5 DNS Express, which is something you can achieve in memory to give a much faster DNS response, or you could use F5 bind. So then the LDNS gets that information back and sends it to the client. Alright, so let's take a look at a slightly different example. So instead of fully replacing the internal DNS, we're going to leave it in place, and the F5 Big IP DNS is going to use its capabilities as a traffic screener for the DNS queries. So you could probably see this in situations where you want to maybe keep the robustness and management of a DNS tool used for internal DNS, and then also use the capabilities of the F5 DNS. And you would maybe see this in an environment of a service provider network where they're able to have a physical presence between their local DNS server and their big IPs. Okay, so let's run through the steps. So the listener address destination is going to be the internal DNS server. So it's kind of a way to not spoof, but really act as a transparent catch before it gets to the DNS server. So it's going to ARP for those queries over the internal DNS server. Okay, so a request comes into the local DNS, sends it to the IP DNS systems, to the internal DNS server that we've configured. And if the F5 DNS does not match, or if the F5 has a wide IP that matches, then the F5 responds with the record and sends it back to the client. If it doesn't have a wide IP, then it will forward that traffic or that query to the IP address of the real DNS server. So it either routes or it forwards the query to the DNS server. Then the DNS server can simply respond like it normally would back to the LDNS. So this gives you the capabilities to act as a traffic screener and really provide a lot of protection to your back end, where you maybe want to keep some of the DNS management tools that you have. So throughout this series, you'll be able to start to see the different features that DNS provides and why you would want to use it as a traffic screener, which we'll get to. Okay, and a slight variation of a different design, and this is the last architectural design we'll discuss in this series, is DNS in front of a pool of DNS servers instead of just one. And notice there's no physical switch between the LDNS and the DNS server. Okay, so in this case we configure the destination instead of a transparent kind of flow from the previous to use the internal DNS server. Now we actually specify a specific IP listener of F5 DNS that is unique to the F5 DNS platform, right? And then the load balancing method under that is a new pool that we create. It's called DNS_pool as an example, and then you would configure in this case three IPs of those DNS servers. All right, so let's take a look at a request, a normal A record request, the LDNS to the specific IP listener, and if it matches the request, it responds back with the IP. If the wide IP does not match the request, then it forwards the DNS query to the internal DNS server. And what's different about this too is that you'll use address translation so that the request is routed back to the F5 DNS. So that's what's different in this situation, is it goes back to the F5 DNS where it handles everything. It's not able to just kind of bypass it like it did previously. So we'll use address translation, so it's routed back to the F5 DNS with the proper IP. Then the F5 DNS will respond with the record it receives from the internal DNS server. And you'll notice that there is priority 2 and priority 1 and priority 1 listed here, 3 servers. The highest priority member will take the traffic first. So in this case, using priority member activation, it'll always go to this first server on priority 2. Okay, so if this server goes down, it'll start using both priority 1 members. We'll talk a little bit more about priority groups as well, but this is just a little tease before we dive into that feature. Okay, so in summary, I hope you got a lot out of deployment models surrounding big IP DNS. We talked about 5 main ones, and of course you can integrate those, maybe 1 or 2, into the same type of model, or you can just stick with one. I really hope you got a lot out of it. That was part 1 of Objective 103. We're going to be jumping into part 2 of Objective 103, talking about big IP DNS features. So I'll see you in the next one.